Hello everyone, welcome to CodeChef. Myself Jwala Charasi and today we are going to solve the problem which came into Starters 201. The name of the problem is mark points and the problem code is MARKP. The difficulty rating of the problem is cakewalk and the prerequisite is adopt. Let's start with reading the problem statement over here. So guys, problem says there are n equi-space points number 1 to n. Initially all points are unmarked. In one operation you can choose x such that x lies from 1 to n and then mark point x minus 1, x plus 1. If any one of them were already marked, they do not get affected. Finally, you will make a binary string s where s of I equal to 1 if and only if you mark point I and otherwise s of I equal to 0. Now you forgot what operation you did. You have a binary string s with you. You want to check if it is possible to obtain s by doing sum of the above operation of marking points. Print yes if it is possible to obtain s and no otherwise. Input format. The first line of input will contain a single integer t denoting the number of test cases. Each test case consists of multiple lines of input. The first line of each test case contains n, the number of points. The second line contains s, a binary string. Output format. For each test case, output on a new line yes if it is possible to obtain s and no otherwise. Constraint for t lies from 1 to 100, for n lies from 3 to 100, s of I belongs to 0, 1. So guys, now let's understand the sample test case and the question more precisely over here. So guys, this question is pretty much straightforward to understand. It says that there are n equi-space points numbered from 1 to n, okay? And initially all points are unmarked. In one operation, you can choose x so that x lies from 1 to n and then mark x minus 1, x plus 1. If any of them were already marked, they do not get affected. So finally, you will make a binary string s where s of I equal to 1 if and only if you mark point I and otherwise s of I equal to 0. Now you forgot what operation you did. You have a binary string s with you and you want to check if it is possible to obtain s by doing some of the above operation of marking point. So we have to print yes if it is possible to obtain yes and no otherwise. Okay. Now let's take the first test case. In the first test case, we have 0, 0, 0. Okay. So in the first test case, we have got 0, 0, 0. So over here, if you focus that, if you mark any of the point, so the point before it and the point after it will also be marked, right? That is in total 3 points. Okay. So yeah, it is possible to do it over here because if I mark point this, so I can choose this, so or any of the points, so all of will become 1, 1, 1, right? So yes, if it is in the set of three, we can make it. So output is yes for this test case. Okay, now let's take one more test case. Okay, this is the test case, guys. So let's say I take test case as 0, 0, 1, 0, 1. Okay, so let's say we perform first operation with x equal to 2. This over here. So let's say so it will become 1, 1, and this remains 1, and then this. Okay, so this will also become 1. So yeah, so now it is possible over here. So output is again yes. But for this test case, right, third one, you cannot make it because in one of the case there will be a place where it won't be a set of 1, 1, 1. Okay, so that is a set of total 3. So guys, I think this test case is pretty much clear. Now let's move towards the simple solution. So in terms of the binary string, what we can do is effectively start with binary string with all zeros and then each operation set 3 consecutive elements of s to 1. Since we can only set 3 consecutive elements to 1, observe that s can never obtain a block of ones of length 1 or 2. That is, cannot contain 0, 1, 0 or 0, 1, 1, 0, right? So I'll start with 1, 0, 0 and so on. So as long as this condition is satisfied, it's always possible to reach the target string. A simple way of doing this is consider a contiguous block of ones from index L to index R where R minus L plus 1 is greater than equal to 3. So the block has length greater than equal to 3. Perform operation by choosing the indices L plus 1, L plus 2 up to R minus 1 in order, and it will result in exactly all these indices obtaining the value 1 by not changing any other indices. Repeat this for each block of ones to obtain the final string. So quite simply, the answer is yes if every maximal contiguous block of 1 in S has a length greater than equal to 3 and no otherwise. This is easy to check. Just compute all block of ones and see if their lengths are greater than equal to 3. Computing all block of ones can be done in linear time, though the constraints are small enough that implementation in O of n square or O of n cube will work too. So guys, I think the solution is pretty much clear. Now let's move toward the simple C++ code. So guys, this is my simple C++ code. I took the input for all the test cases as well as my string. I initialize answer equal to yes and p equal to 0. I'm running a for loop and doing my operation, and at the last I'm simply printing my answer. And as you can see that guys, I have got my C++ code right. Now let's move toward the Python code. So guys, this is my similar Python code. I took the input for all the test cases as well as my string. I initialize answer equal to 0 and p equal to 0. I'm running a for loop and doing my operation, and at the last I'm simply printing my answer. And as you can see that, guys, I have got my Python code as well as right. So guys, I think the solution, the code and the approach was pretty much clear. Now let's meet in the next video. Thank you so much guys for watching our videos.